me Kenji or call me Leo. I'm from Singapore, based in Singapore, but my key job or responsibility cover the entire Middle East, Asia Pac. And I'm a technical lead engineer for this all the energy performance contracting project within Siemens. First of all, I will just run through quickly or share through a few of all those topics in terms of how we determine the energy saving measures and how we actually go about doing energy audits and studies. And some of those, the other points about the energy management and tracking, or in short, we call MMV, measurement and verification. And I hope that these sharing sessions helps all of us to learn from each other. And feel free to ask questions at the end of the sessions. Okay, first of all, in all facility or process, okay, when we conduct looking into energy conservations, so it varies within different industries. Varies in terms of what type of facility types there is within the building itself or the premises, or in terms of services, and what kind of energy has been used. And then with the type of energy use or system that's available, what are the applicable, we call ECM. There's many of these terms being used in the industry. In general, we will use this term ECM, energy conservation measure. And also within the whole premises itself, in order to actually carry out any energy study or we call improvement work, there's certain information that we need to actually have or acquire that before we can take the next step. So in first part of it, we talk about the availability of data. In terms of availability of data, we will be looking at what are the data from either existing measurement system, so-called either your SCADA system or your energy management system, or even from your building. And with that information, we also will be require the system parameters, the equipment that's being used in the building. And the other thing is on the resources side. What are the resources is available for us to carry out any of these studies? Hello, sorry, can you hear me? I'm having some problem with my mic now. Okay, so what are the resources they available? So in terms of the domain expertise, the people who are running the system or the operator level, and what are the competency skill set actually available? And also in terms of instrumentation, what are kind of measurement instrument that is available within the facility itself? And then knowledge and experience. And in terms of doing out all this measurement, what is expectations? Okay, what is expected investment or returns? And what is in terms of the issue that you're facing, not besides just design, maybe maintenance, and also any regulatory requirement on the local itself, or even company policies. And to start off with all this, hello, sorry. Any question coming up from there? Hello, sorry, can you hear me?
Yes, Kenji, we can hear you.
Yeah, I'm sorry, I'm having some problem with my mic. It's just a battery flat. Sorry. Okay, so and in adopting all those energy study, in most industrial sites, we will still follow the ISO practice. So in the ISO 50001, you talk about energy management system. So the program they need to establish to actually carry out all these energy studies. And in terms of the final outcome objective is to actually I would say improve the facilities. And in general, most people were expecting to get benefit in terms of the reduction of the operating costs and energy consumption. And before we can get to all this project and study and understanding the system, so we also need to carry out one activities we call energy audits. And in energy audits, preferably it will be carried out by experienced individual or professional. And within the industry, actually, they will have actually the certification for energy managers, or in some country, or they will also have certified energy auditors. So this will be the individual that is being so-called being accredited or trained and practice in the industry. And the purpose of energy audit is to establish information. And the information that we are looking at is when we talk about improvement that has been done. So in order to justify that, so we also need to be able to establish a proper baseline, which is a point of reference that we're starting all the improvement work. And then we also have to come up with a certain area of studies that where are the area improvement, or where are the area for even at times you do some rectifications. But after you finish all this work, how do we quantify that or justify the improvement that is done, is genuine? Which means that it should not be something that by guess or by basing the reference to industrial what others doing. An energy audit purely expresses facts and data based on your system. And this system actually is based on throughout also the energy data that's been collected and the system installed within the building. So energy audit will not be a kind of so-called a standard practice that report you can just duplicate use from building to building. It's actually unique for every building or every facility or every premises. And what we actually, end of the day, what we are trying to do in energy audit is to find facts and data and understand the building, understand the system, to explore area or room for improvement. And all this room improvement, end of the day, unless it's we call a capital replacement, that you need is time due for the end of life cycle of the equipment. So you will just need to get a budget to get it replaced. But in some cases, you may come across equipment has been installed and actually is still within the life cycle. So this energy study and with the audits that we carry out, it help us to establish facts, to make justification, to make sure that whatever actually the project they implemented is actually give the benefit to the end user or the building owner. We have a acceptable payback and return. And more important, when we talk about energy saving, it should not be saving at the expense of comfort or disrupt to the operation. Disrupt the operation in terms of facility itself, industry. The main revenue source is not come from the comfort or aircon itself for human, but more or less is to make sure the production line, the operation line is running using the energy at the right time and effectively. So that helps to reduce the operational cost and make it more competitive. And in audit phases, usually we will divide them into 3 stages. Investigation phase, monitor phase, and analyze and reporting phase. So investigation phase, this is where we talk about the energy audit. Okay. And in audit itself, it depends what level of audit you are doing. The audit actually, they also, under the SO standard, you also categorize into 3 levels, or in ISO, it categorized into 3 types. And in short, type 1, or we call level 1, is a basic audit. And simply, it's just to more for like, I will say, is to quantify or qualify the building, whether there's a potential or there's any room for improvement. And this actually will be a basic, a quick survey tool with certain, there will not be much detailed work involved, but rather you are looking at the identify the potential. From a business side of view, if we're a service provider doing energy audit or doing an energy project itself, you will have used that method or use this approach to qualify the potential of the business, whether that is a business case. However, if you based on the building owner like yourself, you occupy the building or you are the operator itself. So these tools actually give you a first step to understand your building or your facility. Where are the area that there's opportunity or for room for improvement? The second level type of the that will be require certain measurement, and this measurement it can come from some we call a handheld instrument, or at times we also make use of the instrumentation available on site or within the facility to actually more or less to consolidate, collect data for us to do, or for you as an energy guy to do a understanding, evaluation of the potential. And you eventually come out with a proposal. And this proposal is not be going for in terms of quantity, but rather it should be quality. Quantity means that you do not require to write a report with 100 pages. And what we are trying to do is for level 2 audit or type 2 audit is identify the area of potential and categorize them. And in terms of we call a short term, medium term, and long term. And the last type will be we call type 3 or level 3. So in general, if you hear about energy audit or detailed feasibility study, DFS in short, or in some part of the country or the world, they call IGA, investment grade audit. And this is where the majority of the work involved, and it's quite extensive, which means that physically there will be instrumentation deployed across the system, or that they will be conducting any studies, and time will be spent on site to look at the facility, understand how the system works, but not just looking for problem that the system is facing. And then at the same time, with this study itself, after you collect the data, you also will do some review and analysis, come with some improvement measure or proposal. And with all this improvement proposal, you also will require to communicate with the vendors, suppliers, or contractors to get certain budget or indication of cost to invest. And that form out the entire proposal as the investment to improvement work. And with all this improvement work, also versus based on the analysis that you carry out on the energy data, that what are the potential of energy reduction or energy saving, that would actually help you to substantiate your proposal and translate that based on a term called ROI, return on investment. And all this involve measurement involve, it may not be 1 day or 2 days. In some system itself, you may have to deploy the instrument there for at least 3 weeks to 4 weeks. And that helps us to carry out a more detailed data collection that enable us to understand the system it runs, not just for a day-to-day routine. During energy audit, we also try to understand the equipment from its start to its maximum operation, or we call loading. And at every stage, what are the energy consumed and how the system respond to the demand or the requirement from the ground or the field site. So that's a 3-level audit. And what is needed in all these audits? Okay. And what we need is all the information for the process itself. And by the way, for energy audit, it can be so-called defined on a certain location basis. For example, you can carry an energy audit for a whole production plant or full facility, or you can only carry out this only within your production line, okay, in terms of the compressor system, or you also do it sometime in the entire, like in Singapore or in this part of the region that we use a lot on air conditioning. So very commonly also you will see people conduct audit just purely on the chiller plant and how the chill water system or the aircon system is being used and what's the performance. And with all this information that you want to collect, what actually we are trying to establish, we call the baseline, the point of reference, and also understand how the energy is being used and distributed across the facility or the production line. And from all this data, you also give us indication on how system perform when it is subject to other certain loading condition, and that's why I established the load factors. And also at times that we're also looking at when the load is at a certain level, how the equipment react. So this will be the study carry out to help us understand better on the equipment. And then find the best way to actually operate the system. And field data collection for level 2 audit, and sometime in some location, I will be open to use also BMS data or SCADA data. But condition is that we need to verify whether all this instrumentation or data collection or collected from the field site, are they actually logical or are they realistic? So this will be some form of we call a validation of data before you actually use the information or collected data as analysis. And that boils down a lot that how much actually the budget available. To conduct a full detailed audit itself is not cheap. Okay, reason being that the deployment of instrumentation from the service provider and the amount of effort required, not just to purely just get a temperature of the we call in the space. At times, we may even require to shut down a system to install a power meter, for example, or even we need to open up your installation either on a hot water system or on a chill water system to actually install the instruments. So all this require cost, and that's actually why it will not be a free service. And in terms of collection, whether it should be what type of collection method to be applied, whether you should do on we call per minute a sampling type. Of course, in Singapore, you use per minute sampling in chill water system. So to some part of the world, they feel that Singaporeans are crazy, overdoing. But there's a reason behind.
Good afternoon, everyone. So I think Mr. Kenji have given you a detailed explanation of what is all the audits about. So I will do a simple explanation of how audit process is being done in a simple way, or it can be a cost included a big cost to do the audit, no? So let me go through. So basically, the flow of energy audit program, right? You conduct an energy audit. So basically, when you do an energy audit, it can be you can engage an external consultant to do the energy audit into what details you want to do. You know, like what Mr. Kenji have explained to you, it can be very expensive if you want to do a very detailed energy cost. Or you can actually do a simple one, which is give you a first indication what is your energy is all about, you know. So then if you know there's a big potential saving in certain area, then it's right for you to engage the right consultant to do the detail audit. So identify the potential saving and then propose the energy saving and plan costs of implementation and implement the energy saving projects, right? And then based on that, you will know what is your cash flow and your return of investment. So then you use MNV to do the monitor the saving and maintain the maintenance of the system. So basically, once you do a audit, right, it can be a, a detailed audit done by external consultant, or you can have your local consultant, or you can have your engineers in your plant or facility people to do this, you know, like you can do an initial one just like using a power logger to measure all the power used by the plant, as you know, your major usage could be your chiller plant, compressor plant. So you know the main incoming to your chiller plant, you can measure that, and you do a kind of like a plot this chart, right, a pie chart, to see what is the percentage of chiller plant been using, how much is a compressor plant is using, lighting, you can if you cannot measure from your main incoming, you can measure from you can count the number of lights and measure 1 or 2 units, and you can get this percentage. So this will give you a rough uh, idea what is your energy being used in your plant, So basically straight away we go to the chiller plant, right? So the major usage in any building or facility is chiller plant, right? Chiller plant or compressor plant. So so it's good to look into the chiller plant side, which is you can see as earlier Mr. Kenji have explained also, kilowatt per ton, we base on kilowatt per ton. So if your kilowatt per ton is in the range of 1.2 or 1.1, so there is a big improvement that you can do from these numbers to a 0.6. That will give you almost 50% saving of the chiller plant usage, right? So how you can actually get this index as an initial index measurement by your plant? You can actually do this by using a rough estimation of your tonnage being used by the plant. That means if your chiller is, let's say, 1000 ton, you're seeing the running amps of the chiller is like 80%. Roughly you can take it as like 800 ton, right, as your chiller plant tonnage to the building. And by knowing the power usage of the ammeter in the MSP area, you know roughly what is your power being used by the entire plant. That means it must include pumps, cooling tower, and chillers, right? So that give you the overall indication of the improvement that you can do. Let's say you did a calculation, you get something like an index of 1.3, 1.4, So then you definitely need to get the external consultant to come in and do a very detailed audit, which can do a big saving for your plant, right? You conduct a tonnage measurement in the plant. Basically you need to have a flow meter at the pipe side. As what Kenji said, you have to remove the insulation and do the flow measurement, and you have to know the delta T measurement, chill water supply and chill water return. So you see, when you use just a simple measurement, you'll have ended up in a lot of sensor errors. Let's say if you're using a temperature sensor of plus minus 1 degree C, two sensors, right? Your possible error can be 2 degrees C, right? So that's why when you engage the right consultant or right auditor, they will normally use a very accurate sensing points, So you will see that if the design delta T is 10 degree F at 5.56 degrees C, you are looking at an error of 36% error. If you are not using a proper measurement, then the error measurement can be a lot, So normally we will use thermistor probes, which are the plus minus 0.01 degrees C. So two sensors, right? Possible error is only 36%, right? So for the initial one, you can just base on this, and then when you know there's a potential of big saving, then you must engage right people with the right tools to do all these measurement works. So most of the places you see, sometimes you see in the chiller plant, you'll see a chillers pipes. They are closed halfway or 45 degrees close. So this is they are using a throttling method, no? So that's why we are using for pumps use a variable speed drive, which is very commonly used. You can see here if you use a 100% flow, you are using almost 25 kilowatt. This is an example. So if you're using a throttling effect by bringing it down to 60% of the flow, you're looking at 20 horsepower, right? But when you're using a variable speed drive, you're using 10 horsepower. So that's a difference, right? So if you see any throttling method is being used in your plant, you should avoid using this throttling method and look for the variable speed. You can also use this for your air handling side, where you see dampers are being used with what you call throttling, where you control the amount of air which is going down to the ducting. All this you can use a variable speed drive to control the right amount of air, right? in any plant shouldn't use any throttling method, which is a waste of energy. So on the chiller plant, we also can look into the approach temperature, right? Approach temperature is a wet bulb temperature against this inlet water temperature of the cooling tower, which is coming out from cooling tower, which is like over here is like 29 degrees C, which is coming out. And you see in most of the places, right, cooling tower is something that is not many people bothered to look at it because it's an outside of the building, and normally they are just looking the chiller, how efficient the chiller. But you see, cooling tower brings a big impact to the efficiency of the chiller. The lower you can bring down the cooling tower temperature, the more efficient your chiller will become. So you'll have a major saving in that. So you can also measure your outlet temperature. What is your uh, condenser water temperature like? Is it 29, 30 degrees or 31 degrees? So how much can it go down is based on what is your wet bulb temperature of your current location. Roughly 2 degrees above the wet bulb temperature should be your condenser water supply temperature. Sorry. So for chillers, right, basically that's all you can do for chiller plant. Basically improve the system efficiency to bring down, and this will give you the major saving in any building, right? So now we go into a simple explanation on a compressor system. So compressor system is also same like a chiller plant. It's a whole system which compressor plant produce compressor air and used on your product side, demand side. So you see the transmission, right? You have a pipeline transmission. You can actually recover the pressure losses along the pipeline and use if more efficiently the use of the air. So in compressor plant also, plant owners or plant engineers can do a initial first check by doing a leak test analysis in your plant, right? Uh, Leak test, you don't need a big time expert to come and do your leak test. You can just go around the plant and resolve your leak test. So leak test, sometimes you will see the hissing sound everywhere. You should put in an effort to make sure there's no leaks in the plant, right? And on the chillers, on the cooling tower, on the compressor itself, you have a different type of compressor: centrifugal, reciprocating compressors, oil-free compressor, and oil lubricated screw compressors. So most of the time, when people's mindset is always fixed to use a variable speed drive as energy saving. Compressor guys also likes to use a variable speed drive. So you can see it shouldn't be the way of using variable speed drive all the time, because variable speed drive, when you run it at a maximum speed, it doesn't give you much saving compared to a centrifugal compressors. So you must have a mix compressors, where you have a centrifugal compressor as your base compressors, and you have your variable speed drive as your uh, top up compressors, right? So whereas is a wrong way of doing things by just getting rid of your centrifugal compressor and just putting a variable speed drive compressor, right? So the saving is not much if you run a variable speed drive compressor at a very high output, right? So you can see the centrifugal compressors uh, at 100%, they are quite efficient, quite efficient. So when they go below 75%, they have a lot of percentage blow off. You can see in your compressor plant, you will see some hissing sound at the blow off sound, right? So this blow off is actually considered a wastage, right? So that means you are running at part load condition. Centrifugal compressors are not so good to run at part load condition, right? So that's why centrifugal compressors are good to keep it as a base load, and then you use a variable speed drive oil screw or oil lubricated screw as your top up on your compressor plant. So you can see, so you go for when you do this analysis, you will see that you maximize use of your centrifugal compressor as your base load. And when the fluctuating loads, right, you use the variable speed drive compressors, right? So that will give you a maximum saving in your compressor plant. So the other thing that companies or facility owners can do is to find out how is your fluctuation of your pressure points in your compressor outlet point, right? If you it's very easy to do a pressure measurement. You just take out your pressure gauge and you put a pressure transducer and you start doing a logging for every single minute for a period of time, and you will see how is the fluctuation of your pressure points. So if your requirement of your pressure point in your plant is only 80 psi, but you are seeing this type of fluctuation, right? If you go and do the setting of your compressor below 80 psi, your production will be affected because it will go below this line, right? So in this case, this is called artificial demand, which are actually not necessarily being used in any plant, right? So reduce artificial demand, reduce energy consumption and saving, right? So if you see something like this type of line and in your plant, you can get the right consultant to do more detailed analysis and to come up with a saving plan, right? So basically, you can use a flow controller to, if let's say your pressure output of your generation is fluctuating so much like this. So with the pressure controller, you'll have a steady 80 psi as you're required. So this will give you a saving of roughly 15%, 10 to 15% in your compressor plant. If the inlet air is too hot, that means using more energy to compress the air, right? So in your plant, you can go and look at your compressor room. Is your compressor room very hot? If your compressor room is very hot, that means your intake air, which is going through the compressor, and you compress the air to be a compressed air, so you're using more energy, right? So these are the another simple example that you can look at it. Relocating off your compressor plant to a cooler area. Let's say a 3 degrees reduce in your intake air, right, will save up to almost 1% usage of the compressor. So this is quite huge. So or sometimes you can have a proper ventilation system, proper ventilators in your compressor plant, because sometimes you see they have plants that they put the compressor in a room, then there's no much air in fresh air coming in into the building, right? So these are the two areas that you can look at in your building or facilities. Major consumption, let's say chiller plant use almost 40 to 50% of the use of the total consumption of the plant, and compressor plant will use almost 30 to 40% of the total usage. In a facility of a manufacturing plant, this compressor plant and a chiller plant will use almost equal percentage of use. That means if chiller plant use 30%, compressor plant also will use around 30%. So these are the two areas that actually you can look and attack and get the major saving that is possible, right? So the other area that you can look at is the lighting system. Lighting system is quite straightforward. Changing to LED lights, you don't need a consultant to tell you what to do. You can buy the LED lights, and LED lights will change when you change the LED lights with the facility. You can get almost 40 to 50% saving from the usage of the percentage of the lighting system, right? So only one thing you have to be very careful when you buy LED lights. make sure the LED lights don't have a very high percentage harmonics level, right? So nowadays there's a lot of light suppliers selling without telling the clients what is their harmonics level, right? If the harmonics level is very high, then their light uh, pricing is cheaper, right? So in Singapore, it's very strict. Uh, LED lights must be below 10% harmonics level. So that's why you can ask a reference point. Have you all been installed any in any buildings in Singapore? If yes, then you know this supplier is the right supplier you are selecting, right? So you know what it will be the effect of if the harmonics level is high in any building. So it will make the neutral cables, your main incoming neutral cables become hot, and this will have a problem in your heat, and it can also cause fire in the plant, right? So care must be also taken into harmonics level. So if you have harmonics level high and reducing the harmonics level, you are not going to get any saving. But in terms of safety, it's very important to check the harmonics level of your plant, right? So to measure the harmonics level, of course, you need to get the right uh, people to do the harmonics level measurement. Uh, why you can if your neutral cable, I mean incoming temperature is hot, you know, when you touch it, it's like very hot. So you roughly know these are the symptoms of harmonics level present in your plant. So you have to do quickly a harmonics level measurement. And the other thing is, if you have a lot of electronics equipments in the plant keep on failing, that means if like you have a controller failing, BMS system failing, and a tripping of your breakers, right? This is all the cause of harmonics level is high in the plant. So I'll finish up with my slides with the three examples of what kind of savings that you can get by just doing a chiller plant by engaging the right people, right consultant. You can see uh, the investment for chiller plant can be huge, you know. It can be like millions, you know, but the payback is very good. It's sometimes it's less than 3 years payback. So putting in a 3 million in a bank and putting in investment in this type of project, you will definitely get a good saving. So this is an example of Grand Hyatt Singapore. You can see this investment amount was 2.3 million Sing dollar, and annual saving is around 1 million Sing dollar saving. So the payback is 2.19 years, and based on the tax credit Singapore government have given, so the payback become 1.6 years, right? So